Hello, class. Today we'll be looking at formation of ions. The objectives we'll set to achieve will be to be able to define an ion and explain how an ion is formed. We'll also be able to distinguish between cations and anions based on electron loss or gain. We'll also describe how elements in group 1, 2, 6, 7 form ions with electronic structures. We'll also be looking at some of the electrostatic forces are responsible in holding ionic compounds together. And we'll be doing some illustrations. So the first thing is for us to look at what an ion is. You see, an ion is an electrically charged atom, okay, formed when an atom or group of atoms lose or gain electrons, okay. They do this so that they can achieve full outer shell electrons, which are synonymous to those of the noble gases. A good example of these noble gases are your helium, which has a duplet structure. What we mean by duplet structure is that it has the first and the highest shell of it completely filled by 2 electrons. And when we say octet structure, we mean for those of argon, those of neon that have complete 8, electrons. This ensures stability in atoms. And that is why the atoms of group 0 element are relatively stable. They are very stable because their outer shell electrons are complete. Okay, so atoms of group 1, group 2, group 6, group 7 element also wants to achieve stability. And the only way they can achieve stability is by either gaining electrons or losing electrons so that they can have the type of electron configuration that the group 0 elements possess. So how are these ions formed? Let's start with the anions, the group 6 and the group 7 elements. The first member in your group 6 is oxygen. And so when we look at oxygen, for example, oxygen has an atomic number of 8. Okay, and that means the K shell, we have 2 electrons, okay, and then the L shell will have 6 electrons left. Yes, 6 electrons. So that's 1, 2, 3, 4, 5, and 6. Okay. Now, the inner shell of your oxygen atom is completely filled because the maximum electrons the K shell can take is 2, while the other energy levels, L, N, can take maximum of 8 8 electrons to achieve stability. Okay, but in this case now, we have our K shell to be 2 and our L shell to be 6. Our L shell is supposed to be 8 and not 6. So it's short of 2 electrons. So for oxygen atom to achieve stability, it has to form an ion by gaining how many electrons? Because it's short of 2 electrons. So it will gain 2 electrons. By the time 2 electrons come into this, you have two electrons at K energy level, K shell, and then you have your 8, okay, 8 electrons now instead of 6 electrons. So the fact that you gained 2 from another atom to make this up to 8, we have to indicate that here with a charge of 2 minus, okay, which shows that 2 electrons were gained from another atom to attain stability here. And that becomes K, of course, is 2. And now L equals to 8. Okay, so if we are to represent this symbolically, we'll just say O has changed to become O2 minus. Okay, so the 2 minus indicates that this is now an anion. Call this anion. Okay, and if you will recall in our previous videos when we treated atomic structure, we're able to tell the number of protons, neutrons, electrons in an atom. Okay, this topic will also help us to be able to tell number of protons, neutrons, and electrons in a cation or anion. So in this case, when you have something like this, you know, your proton, number of protons here, proton equals to 8. Number of electrons, of course, will also be equals to 8. And then number of neutrons, of course, is equals to 16 minus 8, which is still equals to 8. Okay, that is for the oxygen atom. But for the anion, the ion of oxygen, the ions, you have your protons is still the atomic number, which is 8. But this time your electrons have increased by the 2 that it gained from another atom, and that becomes 8 plus 2, which is equals to 10. Okay. So that's the only thing that will be different from the subatomic particles present in your ions. This also still remains 16 minus 8, which is equals to 8. Okay, so they follow in that order for anions. Okay, so that is how anions are produced. Now let's take one example of cations. Okay, when cations are formed, what happened to their subatomic particles and what charge do their ions possess? So cations are formed by metals, okay, while the anions, like we treated earlier, are formed by non-metals. And that is why we picked oxygen, which is in group 6. You can also pick elements from group 7, okay, and group 5. So 5, 6, 7, they basically form anions because they are non-metals. But for group 1 and 2, they are strictly metals, and hence they form what we call cation. So let's look at sodium, for example. Okay, so sodium or lithium. Okay, so for the sake of time, I will pick lithium, because lithium is just 3. Okay, so if we are to spread lithium, the electrons distribution will be The K shell will take 2, okay? And our L shell will take 1. Okay, so there is a challenge here. The challenge here is you have an incomplete outer shell, which has just 1 electron. It's supposed to have 8. Now, it will be needing 7 to make it complete, or rather lose this one and be left with the complete inner shell, which is K shell. Okay, it's easier for this lithium atom to give off this 1 electron and remain complete at the K shell level than for it to gain 7 electrons. So that is where cations formation comes into play. So this is the atom for lithium, but when it decides to give away, this electron, okay, away, it forms this. So we have to account for the electron loss, which now will be indicated with positive sign of +1. Why did we use positive sign to indicate loss for cation? The difference or the reason is because now your protons are more than your electrons. Okay, so and that is by 1. Okay, so let's look at what I mean by that statement. You have, for lithium atom, you have protons is equals to 3. Your electrons is also equals to 3, while your neutrons is equals to, of course, the mass number 7 minus 3, which is equals to 4. Okay, and then for the ions, the cation that we have here, you have protons, still 3, because that's the atomic number, doesn't change. But your electron, of course, in this context, you have lost 1 electron to become 2. So the number of electrons in lithium is now 2. And then the neutron remain the same, 7 minus 3, which is 4. Now, if you look at this, you have 3 positive charges, that is protons, in the cation of lithium, and then you have 2 electrons. So there will be a net charge of +1, +3 minus 2. Electrons are negatively charged, so having 2 electrons means -2. Protons, on the other hand, are positive charge, so having 3 protons means +3. When you look for the nets, add them up, you get a +1. That is why cations have positive charge, and anions, on the other hand, which have more electrons than protons, have a negative charge. So we'll stop here today. I hope you gained a lot from this video. To get more videos like this, just make sure you subscribe to our YouTube channel. Click the button below so that you don't miss out from latest videos that we keep on dropping on this platform. And ensure you like this video. Until we meet again, stay blessed.